Find all points of discontinuity of f, where f is defined as this big set of expressions. So we have for less than or equal to minus 3, we have it to be modulus of x plus 3. Between this it's minus 2x, and more than 3 it is 2x plus 2, 6x plus 2 actually. Now the funda here is we have to check for each interval. So let me show it to you guys. So this is your graph. So we have the function to behave in a different manner till 3. I think it's minus 3, right? And after that it behaves in a different manner. And I think again at 3 it changes. So the only point of discontinuity is at 3. Everywhere else is continuous. Now I want to remove this modulus and re-express in terms of a normal expression. So that would be minus x plus 3. The reason being, since all of these values will be by default negative, we'll have minus 1 multiplying with the value of whatever the input value is. Minus 2, minus 1. We have to make it, sorry, not minus 2, minus 1. Minus 4, minus 5. All of those inputs we have to make it positive. The only way we can make it positive is multiplying with negative. Again, I hope you guys remember modulus, how it behaves. Right? So negative input turns into positive by multiplying with minus 1, and positive input will remain the same. And this is for x less than 3 and minus 2x. If we have x between 3 and minus 3 and 6x plus 2 if x is greater than or equal to 3. Now let's take case by case. Case for x or c belonging to R and c is less than minus 3. So what do we have? We have limit extending to c f of x, which is equal to limit extending to c. The expression is minus x plus 3. And this is equal to minus c plus 3. While in general we have f of c to be minus c plus 3, which is equal to limit f of x as x tends towards c. We'll conclude that it is continuous later on. So let's not talk about the continuity over here, at least not in the statement form. We are talking about continuity actually. So now we will look into value between 3 and minus 3. So in this case too, we have a similar set of writing. So let me, okay, it's okay, I'll write it off. So we have f of c in this case is minus 2c, and we have limit, I don't have space for that, so we have limit f of x as x tends towards c. In this case the behavior is minus 2x, and yes, here too it is continuous. And now we can talk about the next one, case for x greater than 3. So we have the behavior to be, here too it's fixed. So this is 6x plus 2, 6x plus 2. So this is 18 and 20. As you can see here, if I reduce this, yeah, it's 20. That's correct. And then we have not limit, f of c over here will be, wait, how did I get 20? My bad. C. I was thinking something and I wrote something. So this is 6c plus 2. And this is limit f of x as x tends towards c. Okay. Now finally we have two different cases. Case when c is equal to minus 3. So we can approach the limit from left hand side, right hand side, because the behavior differs. So when we approach the value of minus 3 from the left hand side, so we have the limit to be, let's see what's the behavior. Minus 3 is minus x plus 3. And so this is minus 6. While from the right, I have f of x limit from the right we have minus 2x. So this will turn out to be minus 6. And finally we have f of minus 3. It takes on this behavior minus 6. So it is continuous here too. Again, we'll not conclude the answer over here. We'll write everything and then show the answer. Okay, last case. We have x is equal to 3. Again, we can approach it from the left hand side and the right hand side and so on and so forth. So actually let me do this. So instead of wasting both our time, I can just, of course the behavior changes, but the writing will remain the same. My bad. The writing will remain similar, actually, not same, similar. Okay, this will change. Oh, this had to change over there. It's not right. This will change, and this will change. Okay. Now, let me change this off. This negative 3. Right? Now, on the right hand side, or left hand side to be precise, actually, I should start with left hand side, minus 2x. So the behavior is minus 2x. So here it is minus 2x. Right? When we are approaching from the left hand side, it is minus 2x. And on direct substitution, I'll get minus 6. And on the right hand side, we have a different answer. Actually, I don't need to do this also. My writing would have been less. I could have finished it by now. F of 3. F of 3 is, as you can see, it will take on this behavior, that is 6x plus 2. So basically, it is 6 times of 3 plus 2, which is clearly 18 and 20. And finally, we can conclude that f is discontinuous. Again, they want us to discuss discontinuity. I hope I'm not wrong about the question. At x is equal to 3 only. I think it is that. Yeah, find all the points of discontinuity. That's all. Don't conclude anything else. This is enough.